All right, guys, this is just a A3 recap for anyone that's struggling with preparing for the test tomorrow, with kind of the three main topics that are going to be on the test. So first we got radicals. Okay, so here's the question that I gave you on the back chalkboard for the sample test. Okay, so if we want to simplify this expression, like multiple ways to go about it, what we can do is maybe the first step you want to take is looking and seeing if you could simplify any of the radicals into, products of something like perfect squares. So numbers that jump out at us are numbers like 4, 9, 16, 25, 36. So all those numbers are like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So they're all numbers that when you take the square root of them, they're going to be a whole number. So if we look at root 20, we know that can be simplified into root 4 times root 5, because we know root 4 times root 5 is, and we like to do that because it turns out the square root of 4 is actually 2, which means we can simplify root 20 into 2 root 5. Okay, so I'll do that on the next line. So then I got 2 root 5, which I can't simplify because 5 is just 5 times 1. That's not going to help us out. And then this situation here, I know I can actually simplify this root 8 into root 4 times root 2, but instead I think I'll multiply them through first. So when you're multiplying radicals, it's kind of like they work to variables, I guess. So we're going to actually multiply their coefficients, and then we're going to multiply the number under the radical signs. So we're going to multiply the 3 and the 4 together to give us negative 12, and then I'm going to multiply the 2 and the root 8 to give me root 16. Okay, so that was my first step. Next step, I'm going to simplify this root 4 because I know the square root of 4 is actually 2 root 5. So you'll notice this root 20 actually got simplified into 2 root 5. And then we have another 2 root 5 that we haven't done anything with. And then this 12 root 16, I'm going to look at this root 16 and I notice, oh my gosh, the square root of 16 is actually just 4. So I had a 12 there, and now I'm going to have times 4 instead of root 16. And just to finish it off, since these both have square root 5s, that's kind of like they're like terms. So if they're radicand, that number under the root sign, if it's the same, you kind of treat it as x. So then we just add the coefficients. So 2 plus 2 is 4, and we just keep the root 5. And then I can multiply these by each other, which is 12 times 4 is 48. So my final answer is 4 root 5 minus 48. So this is a simplified version of that giant equation we started with. Okay, let's try another radical one. So let's say we have a couple of binomials here that are multiplied by each other. So let's go ahead and expand them. So I'm going to start with the 3, and I'm going to multiply it by everything in the second bracket. So 3 times 2 is 6, and then 3 times negative 3 root 2. Well, I just multiplied the numbers together, so 3 and 3, that's 9. And I just leave the root 2. So I'd have 9 root 2. Okay, moving on to the 2 root 6. If I had to multiply that by 2, I know it's going to be positive. And the 2 times the 2 would be 4. I'll just leave the root 6. And now I'm going to multiply these guys. So they each have a coefficient. So positive 2 and negative 3 would make a negative 6. And root 6 times root 2 would make root 12. So when we're multiplying radicals, we can multiply the number under the radical sign together. So the 6 and the 2 just multiply together, which is different than adding. We can only add them when they have the same radicand. All right, so now we got to go through and clean this up. So I notice I don't really have any like terms. Like none of these radicals are the same, so I can't do any. But I do want to see if I can pull out any perfect squares. So turns out this root 12 is actually root 4 times root 3. So I'm going to go ahead and make it, I'm going to simplify that. So since root 12 is root 4 times root 3, I know the square root of 4 is actually 2. So therefore I know root 12 is actually 2 root 3. So I'm going to put that in. So 9 root 2 plus 4 root 6 minus 6, and then I've got this 2 root 3. And now all I can really do is multiply the 6 and the 2 together. So I got 6 minus 9 root 2 plus 4 root 6 minus 12 root 3. As far as we can go because root 2, root 6, root 3, all different. So we're done. Okay, second topic was rational expressions. So in this section, we're going to be either adding, subtracting, multiplying, or dividing, one of those. So if we're adding or subtracting, we have to make sure our denominators are the same. If we're multiplying and dividing, we don't. So I would say like pretty much always your number one strategy is to factor everything you can. Always start with that. If you're like, oh, I have no idea how to do this, at least you can factor. So let's do that. So the 3x, clearly you can't factor that. It's just one term. But x squared plus 2x plus 1 is a trinomial because it's got 3 terms. So I know it's going to factor into 2 brackets, something that multiplies to 1 and adds to 2. X plus 1 times x plus 1. Okay, and then the second fraction, x plus 1, I can't factor that, but I can factor this guy, and that's a squares because it's got 2 terms separated by a minus sign, and I can take the square root of each term. So the square root of x is x, the square root of 1 is 1, and then I put a positive and a negative in each bracket. Okay, so that's what I have. So now I want the denominators the same. So these guys have 2 x plus 1s. This guy has 1, and this guy has an x minus 1. So you're not going to get rid of any terms. Well, actually you could. Okay, I made a crazy question, but you could actually cancel those x plus 1s. I don't know that that would help you. Yeah, I don't think that would be good. So since this guy has 2 x, that means this guy needs another x plus 1 to make it the same. And if we're going to add it to the bottom, we also have to multiply the numerator by x plus 1 as well. Okay, then this first fraction's missing the x minus 1, so let's stick an x minus 1 down there, which means we have to put it on the top too. So now we've added all that stuff in red so that our denominators are exactly the same. Once our denominators are the same, we'll just write them once. So we have x minus 1, and then we have x plus 1 and x plus 1, which I'm going to write as x plus 1 squared. And then our numerator is just 3x times x minus 1 plus x plus 1 x plus 1. And that's pretty much it, except since I have a plus in between a couple of things here, maybe you want to expand that and collect like terms. The numerator, I think it would clean things up a little. So I'm just going to continue my work over here. So if I had to expand my numerator like that, I would get 3x 3x plus, if I expanded this binomial, x times 1 plus that, 1 times x times 1 plus 1, 1 times 1. Okay, sorry about that. It would expand to x squared plus 2x plus 1 over that giant denominator. I just want to caution you too. If, I'm going to highlight it, if, or not. Okay, I can't highlight, apparently. Okay, if this guy's a negative, you got to watch out. Because if this sign actually is a negative sign, it's you're gonna want to keep this in brackets and apply the negative sign to the whole thing. Since ours is a positive, it's cool, but just be wary. If we're subtracting, got to be careful. Okay, so I'm going to collect my like terms. So 3x squared plus x squared would be 4x squared. Negative 3x plus 2x would be negative x. And I have a plus 1 over x minus 1, x plus 1 squared. You could always check if you can factor the top, but I think in this case we can't. Okay, so that's our final answer. And if we wanted to state restrictions, we would just set each of the brackets equal to 0. So set x minus 1 equal to 0, and that would give us 1, And then if we set x plus 1 equal to 0, that would give us -1. So it turns out our restrictions are x can't equal +1 or -1. And that's how you do rational expressions. And then finally, if you have a division or a multiplication one, you still want to factor first. So let's quickly factor this. So the top is a trinomial. So it's going to factor into x minus 4, x plus 2. Our denominator is 3x minus 1. Since I have a division, switch that to a multiplication and take the reciprocal of my second fraction, which means I'm going to flip it. So that 15x minus 5, I'm going to common factor out of 5, which is 3x minus 1. And this top guy is now the denominator, and it's a complex trinomial. So sometimes I take that over on the side here, and I factor it on the side. So if I was going to factor that, I'm looking for a number that multiplies to -12 and adds to 1. If you're me, I prefer my guessing method. Okay, I know the front of my bracket's going to be a 2x and an x, because that would multiply to 2x squared. And I know the backs of my brackets have to multiply to -6, which would maybe be -2 plus 3. And then I see if that works. So I'm like 2x squared plus 6 minus 2. That doesn't work. So then I try switching them. And then I say 2x squared plus 4 minus 3 minus 6. That works. So I just like guess it. But if you'd prefer an actual method, decomp or crisscross or whatever you call it, you could do that off to the side here. So I'm looking for two numbers that multiply to -12 and add to 1. So I know -3x plus 4x. And then I just split it in half and common factor each half. So I'm going to factor out an x, so 2x minus 3. And then I'm going to factor out a 2, so 2x minus 3. And then I take the one in the bracket, factor that out, x plus 2. So you could just do that off to the side. Okay, so now you've fully factored it. Now I just like to see, since it's in factored form, I like to see if I can cancel anything out. That's what on the top and bottom. So I have an x plus 2 in the numerator, an x plus 2 in the denominator. I have a 3x minus 1, 3x minus 1. So I can cancel stuff out. So that leaves an x minus 4 and a 5 in the numerator. So I'm going to write that as 5 times x minus 4 over, and then I check my denominator and I just have that guy left, 2x minus 3. So that would be my final answer. I wouldn't bother expanding. And then if I had to state the restrictions, I would go back up to this step and I would list everything that could potentially make my denominator 0. So I'm going to say x can't equal this guy, -2. This guy, if I set this bracket equal to 0, I move the 3 over, divide by 2, I get 3 over 2. And then this guy, I would get 1 over 3. So those would be my restrictions. I know this is a quick explanation, but hopefully it's just to supplement understanding from class. Okay, and then finally, the last thing you can expect on the class is just simplifying expressions. And I could just get you to simplify one, or I could say, are these guys equivalent, not equivalent? So for example, one of the ones from the back page of the homework was x minus 3, x plus 2, x plus 5. And you had to simplify that. It's similar to the one I put on the board in class. So if I had to simplify that, if I had to compare it to, I think I gave you guys another expression, g of x, which was x cubed, 4x squared, 11x, 30. Okay, so I said, are these the same? And I'm like, oh, I don't know. So what you want to do is expand the brackets and see if they're the same. So I'm going to do 2 at a time. So if I'm doing these two, I'm going to do x times x times 2, x squared plus 2x. Then I'm going to do -3 times x, -3 times 2. Just -3x minus 6. I'm going to keep that in brackets and then multiply all of that by x plus 5. If I simplify my first bracket, I get x squared minus x minus 6 times x plus, which will end up being x cubed plus 5x squared. I start with my x squared, and all I did was multiply it by those guys. Then I move on to this and multiply it by both of them. So I get negative x squared and then negative 5x. And finally, I go to my negative 6 and multiply it by those guys. So I get negative 6x minus 30. Okay, and then I just collect like terms. So I get x cubed. Okay, 4x squared. And these guys, negative 11x minus 30. And then I compare it to g of x, x cubed plus 4 minus 11 minus 38. Yes, they are equivalent. Awesome. So that is what A3 test. You can watch this video again, pause it, feel free to email me or post in the discussion if you need my help. Good luck.